Assalamu alaikum, students. Welcome to class. Before I start, just have a quick question. Can you hear me? Is my voice loud and clear? Please let me know. Okay, very good. Thank you. Very wonderful. All right, so today I am not going to play a video. I did not have time to record the lecture, so I'm going to do a live lecture. So you will not have auto translate enabled in Arabic, unfortunately, but I'll try to speak a little slow so don't go too fast and it's easy for you to understand. And so today we are basically going to continue with our example of generating random numbers. And we're going to look at another example where we're going to play a game where we generate some numbers randomly. We're going to simulate the rolling of die. So die is the white little cubic things that you use maybe if you're playing some card type of games. But the main focus is not going to be on generating random numbers in today's example. The main focus today is going to be on what are called enumerated or enum data types. And what they basically allow you to do is to map integer numbers or integral data types to strings or assign them names which actually make a bit more sense. And the advantage of using enum is that it makes your program easy to read and understand. So that's the main advantage of this. So we can start with this. So first we're going to talk about what game we're going to play. This game is known as craps. The rules of this game are simple. So a player rolls 2 die. Each die has 6 faces, so it can generate numbers, integer numbers from 1 to 6. So there are 6 possible outcomes, and we're rolling 2 of these. So that means we have 2 die, each of which will randomly produce an integer between 1 and 6. Now this game is based on the sum of the numbers that come out on top. If the sum is either 7 or 11, then the player wins the game immediately. Okay, so if you throw the die and you see either a 7 or an 11, the user will win the game, the player will win. If the sum is 2, 3 or 12, then the player loses immediately. So if you get these 3 numbers, 2, 3 or 12, then you lose. And then the third condition is if all other numbers show up. So numbers other than 7, 11, 2, 3 and 12. So all the other numbers 4, 5, 6, 8, 9 or 10. If any one of these numbers is the sum, then the player basically goes into a condition called point. So what that means is the player has to repeat the game. So you have to throw the die again, and to win, what you might do is that you must reproduce the same number. So if you roll the die and you get the number 5, then you have to repeat throwing the die. So you have to keep throwing them until the time you get the number 5 again. If you get number 5, then you win. However, if you get the number 7 on your second, third, fourth, or whatever try, if you get the number 7, then you lose. So you keep repeating until you either get one of these numbers, which would mean that you win, or if you get the number 7, then you lose. So let's look at how this can be simulated. Right, and so in this example, you are going to be using stdlib.h because obviously we want to use the rand function. So we're going to use the stdlib, we are going to use the time.h, and the reason for these two will become clear. Now the next thing to note here is that you have an enumeration constant which is declared before your an enum data type which is declared before your main function. And what does it do? You have the keyword enum, and you have the name of your that you want to assign your enum data, and then you basically have three names inside curly braces. So you have continue, won, lost. Now this basically represents the status of the game. And what the enum data type basically does is at the back end, it basically assigns integer numbers to the names that you put inside these curly braces. You can assign them integer variables, integer values as you want, but by default, the values that are assigned are the first one gets assigned the value of 0, the second one gets assigned the value of 1, and then the third one is assigned the value of 2. So although they look like strings or actual readable names, at the back end the compiler actually views them as these three integers. Okay, now the reason why we're using these names is because it will make the program much more readable for us. Now because this is being declared before the main function, that means it will be visible throughout this program. So all functions that come after the declaration of this enum data type will be able to access them. Right, so then we have our main function, and in the main function we are basically first generating random numbers. So this basically simulates rolling the die, and we will look at this. First we're setting the seed, so it's a rand, and the argument is time, which gets an argument of null. So we're basically first setting a random seed, so we get random different outcome every time we repeat this. Then you're declaring an integer variable my point, which basically keeps track of the point in case the game needs to be repeated. And then you're basically declaring this enum variable game status, which will kind of dictate, will be used to see which one of these three game statuses did you see. Then you are basically going to call your function roll dice. And what is the roll dice function? Well, the roll dice function prototype is here. It does not receive any argument. It returns an integer number, and that integer number basically is going to be the sum of the two randomly rolled die that we have. So we will look at the definition in a little while, but this is basically just going to use the rand function to generate integers between 1 to 6. It's going to do that 2 times because we have 2 die. So we first have a switch statement. What does the switch statement do? The switch statement is based on variable sum. And what does it do? Well, as soon as it sees a case of either 7 or 11, so it says okay, user 1. So it basically sets game status to 1, and then it breaks the switch statement. However, if numbers 2, 3, or 12 are seen, then it sets the status to lost, which means the user immediately loses the game. Then the default option, if it isn't any one of these 5 numbers, then basically it sets the game status to continue. What that means is you will have to repeat the die throwing. It sets the sum to my point, so it keeps track of what you observed. And so you have to, if you want to win the game, the rule says you have to repeat the die, so you have to throw them again. And if you get the same number, my point, then you win the game. However, if you get the number 7 as the sum, then you lose the game. Okay. So then we go with the repetition. So we did one try and then we went into the repetition. So now we're going to eat our roll die. So we basically say that if the status of the game is not won or lost, so it has to be continue, because if we win or lose, we just stop the game there and then. But if it's continue, then we have to go inside a while loop. In that while loop, we basically throw the die again. If the sum that is returned is equal to 1 point, my point, then we say game is won. Sorry, I'm trying to draw arrows here. If the sum is equal to 7, then we say game status is lost. And so we repeat this until we get the same number back. And in that case, we say win. And if we get the sum is 7, then we put the game status to lost. And we come out here, and then over here, if the game status is 1, then we say player wins. If the status is not 1 and we are down here, obviously we're only going to be down here when the status is not continue. Then we say the player loses. Now, what is our roll dice function? Well, it's a simple function. We have a die 1. So this is the first die that we roll. We basically simulate this roll using randomly selected integers from 1 to 6. We already know how to do this. So we do that by 1 plus calling the rand function modular division 6. And we repeat this again. So this is the second die. So again, the same statement. So die 1 plus die 2. And then we say, okay, the player rolled these two numbers, and we print their sum, and then we return their sum. So it's a very simple function. Now, one of the advantages that you get, so the main advantage that you get by using the enum data type is, if you did not have the enum data type, you would have had to write what numbers do we have. So we would have 1 here, lost was 2, and this would be 0. Now, obviously, reading this status is 1 continue is probably better than reading this as 0 1 2, because that's difficult to remember. So you have to go back to the top of the program, figure out what this means. So it's probably easier to use the enum than to use this. So that's why it is recommended to use this. Don't have to overuse this, but it is generally recommended use in cases where you want to improve readability of your program. Okay. Right, so let's look at some sample output. So a 7 or an 11, that means the status is going to be, and we basically go ahead and we print wins. So just one try, the user won the game. If we repeat it one more time, let's say sample output is 5. So 5 is among those numbers where the status is going to be set to continue. The status continue. All right, sorry. Can you guys hear me now? I think there was a disruption by Blackboard. Because the internet otherwise was working. Okay, so let me reload my slides. Okay, so let me restart where we were. So were we at this slide when we got disconnected? Let me go back to the previous slide. Let's start from here. So basically what happens is if you get 11, the user wins immediately. Then let's say we run the program one more time, and this time we get number 5. Number 5 basically means that the status will be set to continue, and the user will have to repeat until he gets either number 5, in which case the user will win, or they get number 7, which would mean that the user would lose. Once point is set to 5, the user repeats, and then on the third try, the user gets the number 5, which means the user wins the game. Let's look at some of the lost scenarios or losing scenarios. In this case, the user rolls the die on the very first attempt. The sum is 2, which means the user loses immediately. In this one, it's 10, which means the status is continue. The user repeats and he gets 7, and when you get 7 on repeat, that means you lose, so the player loses. Okay. All right. So what we see in these is just explanation of what we see on the code. So I'm not going to talk about this in too much detail. So the user must roll the 2 die. So yeah, so this just explains what the program is doing. So we don't really. The one thing that you want to note about this is that the program takes function roll dice takes no arguments, which makes sense. I mean, you don't not really giving it any argument, just making it return something. So yeah, the basic thing that we want to introduce is the enumeration data type, and the enumeration data type basically is introduced by using the keyword enum, and it basically is just a set of integer constants represented by identifiers. So what the enum keyword basically does is that it takes the identifiers and it sets integer values to them in the background, right? And the main purpose of this is that it makes your program easier to read and understand. And if you don't assign them any integers by yourself, if you don't assign them different values, the default values are they start with integer 0 and then increment by 1. So 0, 1, 2, 3. So the identifiers that you put in will be assigned these values. This we've already talked about. One more thing that is generally recommended is, so enum are basically constants. So after they have been defined, they are considered as constants because they are defined outside all your functions, generally at the very top. So if you try to assign them different values, because these are kind of viewed as constants, if you try to change their values later in the program, you will get a syntax error. You are not allowed to change their values. So generally use enum data types only for scenarios or for cases where you are not going to be changing values later on. So but not changing. So these are variables that you should not be changing later. Another thing that is recommended is generally to use as names of enumeration constants. And why do we want to use uppercase or capital letters? So they allow you to kind of allows you to immediately look at them and identify that you're looking at enumeration data, right? Because lowercase and mixed types of letter variables and functions as well. So just using all uppercase letters makes it easy and immediately tells you or somebody else who may be looking at your program that they're dealing with enumeration data types. And so that's pretty much it with the example. You already know the rules. You don't have to memorize the rules, but if you run the game a couple of times, they're generally easy to remember. It's not very difficult. We've kind of defined this before. So, so let me just quickly show you this as an example. So I am going to run this program in Visual Studio so you can actually see how it works. I've just typed it here. I noticed that I haven't put the comments here because you can read those on the slides. So I just wrote down the code mostly. So let's look at how this basically works. So what do? We first add our preprocessor directives, and we define the enum constants that we want to. So we have continue. You notice that the comment actually indicates that continue has a value of 0, 1. Come here, 1 base value of 1, and then lost is assigned a value of 2. So then we basically define write down the prototype for our roll dice function, and in our main function we're basically saying sran. So we're just setting the random seed, so we get different outputs every time, and then we basically define these variables into my point, and then here we're calling an enum data type, a game status. One thing that you might note is you get these green squiggly lines below the game status in your main function. When you go up there, this balloon kind of shows you this sort of a warning, or something that looks like a warning, which says the enum type status is unscoped. Prefer enum class over enum. Now this is because C++ generally prefers different things a little differently, but since we're dealing with C, there are no classes here, so you don't really worry about, you don't have to worry about this. So just ignore this. It doesn't really affect anything in C. It's probably useful for C++, but for conventional C, this is something that you can ignore. Okay, so we have our switch. Again, we're assigning 1, lost, continue. Now imagine that if you did not use enum data types, you would have to then go back and maybe I'll put a comment here that game status is equal to 1 means game equal to the number 1 means that the user won the game, and then here lost would be 2, so 2 is lost the game, and 0 is continue, and whatever. So you have to add more comments, and if you don't add comments, then it generally becomes difficult for somebody to understand what this code does. So it will, I mean, they will be able to figure it out, but it will take more time. Okay. So let's run this, and finally, before we do, this is the definition of our roll dice function. Let's run this once and see what we get. And so on the very first roll, the user was unlucky. Output was 1 and 1 again for both die. So the sum is 2. That means the player loses. So no repeats. The status is immediately set to 1, or immediately set to lost, and the program exits. Look at this. This time you get 5. 5 means point is 5, so you repeat. First time you repeat, you get sum equal to 4. You repeat. Second time you repeat, you get sum equal to 5, which is the same as point, and so the player wins, right? So that's how this game operates. Maybe one more time. 11, so this time you're extra lucky. 11 means that you win immediately, so it just goes down this way. Maybe we might want to insert a debug or a breakpoint here for a second and then see what that does. So let's see. We have roll dice, so let's see. We basically, once we roll dice, sum is equal to 8. The sum is 8. Roll die returned 8. And then we go into our switch. 8 is neither of these, in none of these, so it takes you to game status continue. And basically continue, you can see here, corresponds to integer 0. Let's see what happens now. So now what happens is game status is also set to continue, and then my point is set to 8, and then you should get on screen printing of my point. Point is 8. Okay, and then we can repeat this. Now you go into the while loop, roll die again. Roll die is 4, which means it's not equal to 8, so not equal to 7 again. So you go back up, you repeat, you roll die again. This time die returns 6. Again, going to repeat, and now die returns 4. Nothing happens. Now die returns 5. Again, nothing is going to happen. Now you get 10. Keep repeating. Looks like this one is okay. I know it's going to keep. Let me just run it. Right, looks like there was a temporary outage again. I'm not sure how much of it you guys lost. This was the output. So we ran the program and we stopped after a few tries. So you can try this program, you can type it out at home and see how it does. It's not a very hard program to run. So we finished this. Now I'm going to start on the next topic. By the way, I will record this video and upload it to YouTube as well. It is being recorded, so I will upload to YouTube too. So let's go back to the slides. And continue with the next topic, which is basically storage classes. And storage classes obviously is an important concept to remember. And they basically generally affect identifiers So let me find my cursor. So up till now we have used identifiers, right, as names for either variables and as names for functions as well, right? So identifier over here, basically in this lecture, when we refer to an identifier, what we mean by an identifier is that we are talking about either a variable or a function or both. So in this lecture, identifier mostly means, if I say the word identifier, that means I'm going to be talking about variables and or functions, right? If we're looking at variables, when you look at a variable, you will remember that a variable basically, so the it is basically kind of has some characteristics that are associated with it. First one is the name of the variable. In this case will be the identifier. So we could have whatever identifier for our variable. Then the other characteristic of a variable is the type of variable. So let's say we define int var, and int basically tells us that we have an integer variable. var basically is the identifier, so it is the name. So it is the name of our variable. Size is also another characteristic that is associated with a variable. So how many bytes are used to store this integer? And then value. So what is the value that is assigned to this variable, right? So do I set it to something like 0? Do I set it to something else? If I set it to something like 2, that means that I have an integer variable whose name is var. It uses perhaps 2 or 4 bytes to store that integer, and its value is 2, right? Now these are 4 characteristics of a variable. Similarly, you have characteristics of functions as well. So whenever you define a function, you have a name for the function. There are some other characteristics as well that we have not looked at explicitly prior to today's lecture, and we're going to look at those today. And those are basically the storage class and primarily scope. Now, what do we mean by that? When we're talking about storage classes, we generally also have to at times deal with in what parts of our program will be an identifier visible. So if I define this inside a loop, it will not be visible outside of that loop, right? So if I put this inside some sort of body of a loop, and then I try to access it outside, so maybe over here, I will not be able to see this, right? So this is another characteristic of this variable, which is normally referred to as the scope of the variable, right? So it is visible inside here, but it is not visible here. Similarly, if I define a variable inside a function, then normally by default that variable is not accessible in other functions, right? So that is another feature or an attribute of a variable. Similarly, you have similar characteristics for functions as well, right? So some functions are visible in certain parts of the program, and then in other parts they are not visible. We have not really dealt with examples of those, but we will talk about this in more detail today. Okay, so now key point is each identifier. So what do we mean by an identifier? So an identifier can be either a variable or it can be a function. It has attributes like storage class, storage duration, scope, and linkage. I have just told you what scope is. I will talk about the others in a little bit. Okay. So if we're talking about storage class, there are basically 4 types of storage class specifiers. First one is auto. So this is the default one. And what that means is, let me talk about this in a bit more detail later. The second one is registered. Then you have the extern, and then you have the static. So these are the 4 storage class specifier. And a storage class basically determines or has impact on the duration. So what do we mean by the storage duration? The storage duration means how long will the variable be inside the memory. So when will it be created and when will it be destroyed? So we will talk about that. Storage class also has an impact on the scope of the variable. So it will control where in the program the variable can be seen, and then it also has an impact on the linkage as well. We will only introduce linkage but not talk about it in detail. So let's first talk about storage duration. So storage duration is the period during which the identifier exists in memory. Okay. Normally by default, your variables have variables generally disappear after their scope ends. So if they are inside the body of or part of a function, then they will disappear after that body is executed. Okay. So what do we mean by scope? Scope is where the identifier can be accessed or referenced in the program, right? So identifier scope is where an identifier can be accessed or referenced in a program. Okay, there are some variables that can be referenced throughout the programs. There are others, other types of scope, which generally mean that those identifiers can only be accessed in certain parts, right? And then an identifier's linkage basically determines if if you have multiple source files, whether the identifier is going to be accessible in that source file or it is going to be accessible in other source files as well. Now this might seem a little confusing, so I will explain this quickly. So far, all the programs that you have been writing only have one source file, right? So if I go back to my Visual Studio for a second, what you actually see here is that my program basically consists of only one file, which is called enum_rand numbergen.cpp. So if I look at my program, you just see that in my source files, I have only one file, right? That is the case in most of the programs that we have been doing or writing so far. What you can do is inside your program, you can add new sources. You can add another source file here, and you can add more functions inside that, right? Once your programs actually become longer, then it generally is very difficult to write or manage everything inside one source file. What you can do is, for organizing your program, you can create multiple source files. Okay. Now, what linkage basically does is, linkage basically controls whether something that you defined in different source files, whether it will be visible in other source files or not. So if I add another source file down here and I define maybe 3 functions inside that source file, linkage will basically control whether I am able to see those functions inside my current source file or in other source files. One example of linking that you're doing is with the printf and the basic C library functions, right? When you add things like include stdio.h, what that basically allows you to do is it allows you to access the printf function inside your source file, right? Now, the printf function is defined somewhere. It is defined in a different source file. It is definitely defined in C language. You don't see it, but you are able to access it. But you're only able to access it only if you include the preprocessor directive. If you do not include it, then you will not be able to see it, right? So that is what linkage does. But right now we are not going to look at into the details of linkage because we are dealing with simple single source files right now, but we will look at them in more detail maybe in later chapters. Okay, right. So we're going to be dealing with scope mostly. Linkage is discussed in chapter 14. So once you actually start writing much more longer programs, then you can talk about identifier linkage as well. But for now, we're not going to be talking about those. Okay. Now, the storage class specifier can be split into automatic storage duration and static storage duration. Now, let's talk about the automatic storage duration first. The automatic storage duration generally can be assigned using the keyword auto, right? When you declare variables of automatic storage duration, you can write something like auto int x or something, okay? Now, what do we mean by variables with automatic storage duration? Variables with automatic storage duration are created when the block in which they are defined is entered. They exist while the block is active, and they are destroyed when the block is exited, right? So integer variables that you define in some function or in some block, if they are of automatic storage duration, they will be defined when you enter the block in which you have defined them. So they will be created when you enter that block. You can use them inside that block, but when you exit that block, they will be destroyed, right? So they are destroyed when you exit that block. So if you define them inside some block of your function, so if you define some auto storage variables, they can be accessed inside this block. Outside this block, they will be destroyed, and so you cannot access them. So if you try to access them outside this block, you will not be able to see them. Okay. Now, variables that have automatic storage duration are basically referred to as local variables, right? If you define some variables inside a function, they will have automatic storage duration. So they will not be, first of all, if you define some variables inside a function, they will be created once you enter the function. You can use them inside the function, but when you exit the function, those variables will be destroyed because they are no longer needed, right? If you use the keyword auto, it explicitly declares variables to have automatic storage duration. But you generally do not need to write the keyword auto when you're declaring variables, because by default all variables are local variables, so you don't have to write this. Okay, this keyword auto is hardly ever used. It is rarely used because you generally do not use it in any case. Okay, keyword auto basically explicitly declares variables of automatic storage duration, but you don't generally need it because by default all variables are local variables that are declared inside functions or maybe declared inside some body of some control structure. Okay, so you see here, right? So this is rarely used because by default local variables have automatic storage duration, so you don't really need to write the keyword auto. And for the remainder of this text, when we say automatic variables, what that means is we are talking about variables with automatic storage duration. And so why do we need automatic storage? Well, obviously we need that because automatic variables exist only when they are needed. So they are created when a function is entered and destroyed when the function is exited. So this basically allows us to conserve or save memory, right? Because if we are allocating memory to memory locations to variables that we're not really don't really need to use, then it will basically end up being a waste of memory. So we don't want to do that. That's why the default storage type, storage duration of local variables is automatic storage uh, duration. Okay, and then you also have another type which is called a static storage class, and this we can talk about next time. We will start from here with static storage duration and continue from there because we've reached the end of the last time, so we will talk about this next time. Okay, so I'm going to stop recording.